friends and colleagues. I'm going to start my panel discussion with a chart. I'm a journalist at Quartz. We are a global business publication. We are online. It's at qz.com, or for the Americans in the audience, qz.com. And we love charts. The chart here, which might seem boring at first, there's not very much change. It represents the proportion of fossil fuels in the primary energy mix from the 1970s all the way to the current decade. What you do see is there isn't much change. 80% of all energy still comes from fossil fuels. But this chart is interesting for two reasons. It shows the first 2 decades, the 70s and the 80s, when nuclear power took off, and we have about 400 gigawatts of nuclear power capacity in the world today. It also represents 2 other decades of renewable energy that came online in the 2000s and the 2010s. We've talked a lot about the energy transition. What we've really seen in the last 5 decades, or for the last 2 centuries, is an energy addition. We've had a number of carbon-free sources that have come online and have contributed to the primary energy mix. But they've only contributed towards the energy demand growth. From the 70s to now, the amount of energy that the world consumes has doubled. So the panel today is going to talk about how do we use fossil fuels in a world where we need to cut our carbon emissions. Coal is something that we can all understand may have a declining future, but that's not quite so true for oil and gas. Please let me welcome distinguished panelists. We've got Ahmad Khowaiter, Chief Technology of Saudi Aramco, Jerome Schmitt, Executive Committee Chairman of the Oil and Gas Climate Initiative, Adnan Shihab-Eldin, Director General of the Kuwait Foundation for the Advancement of Sciences, Masakazu Toyoda, Chairman and CEO of the Institute of Energy and Economics in Japan, and Mechthild Wurstoffer, Director for Sustainability and Technology at the International Energy Agency. The format of the panel is I'm going to ask a few questions, and then I'll take questions from the audience. So I hope that there is enough stimulating answers you get that you're going to ask follow-up questions, so get prepared. I'll start the panel with Jerome. The Oil and Gas Climate Initiative was launched in 2014. The oil and gas industry as a whole has been doing a little bit on climate change, but the OGCI and its formation created a step change. What do you see that step change looks like today?
I think the first step change, a very interesting one, is that it was launched a year before COP21 in New York at the UN during the climate week by a strong leader, His Excellency Khaled Al-Faleh. And now we are following the path. It was launched by 3 companies at that time. We were 10 a year ago. We are 13 today. We do represent 30% of the global oil and gas production, which means, if you look at this chart, about 20% of the global energy demand supply. And we are truly global. We have CNPC, Saudi Aramco, we have Pemex, we have Petrobras, we have most of all of the international major companies from the US, from Europe, from elsewhere. We have IOCs, we have NOCs, and all these companies are truly engaged on climate as part of a joint roadmap to go beyond the sum of the parts.
In the past year, you've added 3 new companies to your roster. You've got ExxonMobil, Chevron, and Occidental Petroleum, all American companies. It took them a while to join the initiative. What was that hesitation?
I think that, for some of the companies, you need to be convinced that you can effectively contribute to bring the initiative beyond what it would do by itself. And we are not looking backwards. We are looking ahead of us. And I think what is absolutely great is that these three companies realized and made clear that they were prepared to contribute to make sure that the GCI would be better with them and would go further ahead and faster with them than without them. I think this is great, and a great success not only for GCI, but as well, hopefully, and I believe, for these companies too.
Before I go to the next question, Brian, can I get the next chart, please? The next chart shows you the emissions from upstream oil production. You'd see that it varies a lot, starting from Saudi Arabia all the way to Iran. I'm not mentioning Venezuela because not much oil is coming out from there. In that context, Mr. Khowaiter, I wanted to ask you, what is it that Saudi Aramco is doing to reduce the emissions that come from oil? And we can talk about gas later.
Sure. Well, thank you very much. It is a great pleasure to be here. And I think this graph is really interesting because for the first time it shows the heterogeneity of emissions from oil. And we tend to think of oil as being just one commodity. But in fact, there's a huge differentiation. And that's one of the problems that the world faces today, is that we look at oil as one type of energy source, when in fact it's many types. And what Aramco does, beyond the benefits that we have of low pressure production, is we have a lot of technology that we apply in practices. The easiest of which, for example, is eliminating flaring. So flaring is a huge source of CO2 emissions. And Saudi Aramco in the 1970s decided to stop flaring associated gas, even though it had no economic value. It was stranded. We invested billions of dollars to collect that gas, and about 2 billion standard cubic feet at the time, an average of about 4 billion standard cubic feet a day of associated gas had been prevented from being flared for the last 40 years. That's 4 gigatons. 4 gigatons of CO2 prevented from being in the atmosphere, with an uneconomic decision back in the 70s, what it seemed to be an uneconomic decision. The use of that gas established the petrochemical industry in Saudi Arabia, which now represents one of the most important sectors of the economy. Tremendous job creation, tremendous GDP input, and Saudi Arabia is one of the leaders in petrochemicals today. So what we think of as a waste product can actually become a very valuable product. And I like the presentation previously from Bill, which kind of re-emphasizes that. CO2 is a valuable feedstock. We should not forget that. And I think that we've done a lot of work in trying to create that value, in fact, with investment we do in R&D.
Perhaps you can also speak to the point that is specifically on the upstream side. Yes, you have lower emissions than most countries, but it's not zero. Yeah. And the goal eventually to hit climate goals is to reach zero.
Yes.
What are you doing on the upstream side that reduces emissions further?
Very good. So there's a number of things we do in the subsurface and on the surface. In the subsurface, we do a lot of technology such as multilateral wells, which reduce the amount of energy per barrel produced. We do a lot of technology around water injection. So we reduce the amount of water per barrel. So if you look at, for example, the number of barrels of water we inject per barrel of oil we produce, we're 10 barrels less than the world. 10 times less than the world average. It's a tremendous improvement over the energy needed to extract a barrel of oil. We do a lot on the surface. So cogeneration, all of our electricity production we use, and we have surplus electricity we export to the grid, comes from cogeneration in our plants. So all of the heat that is needed is a byproduct of our electricity used in the production of our gas and oil. So this reduces definitely the carbon footprint dramatically. In this case, this study showed from Science in September, it showed around 27 kilograms per barrel compared to a world average of 60 kilograms per barrel. And that's a very important number. If you look at the emissions associated with production of oil, from 15 to 40% of the total CO2 footprint of that oil comes from that production. So it depends on what type of oil, especially the high energy oils, they really put up a lot of emissions. There's huge potential to reduce the carbon footprint of the full life cycle of oil through implementation of technology.
Dr. Eldin, I wanted to ask you about your past life. You were acting Secretary General at OPEC. You were the Director of Research at OPEC. What do you think oil-rich countries can do towards the goal of decarbonization, and what did you see in your time at OPEC?
Well, first of all, I'm delighted to be here at the Atlantic Conference Energy Forum. And I am referring to a period when I joined OPEC in the early 2000s. And at that time, the oil exporting countries were still debating what to do about the climate change challenge. And I am delighted that that gave me a golden opportunity to work with the ministers and national oil companies to set up a consortium of oil-producing countries in OPEC to look at various aspects of how to contribute to addressing climate change. There was an agreement then that the oil-producing countries have a responsibility through R&D, through pilot projects, through integrating solutions within the industry in upstream, as was mentioned here. I just recall one fact. During the OPEC summit hosted by Saudi Arabia in 2007, I believe, a pledge was made by $1 billion distributed among the Gulf countries, essentially with Saudi Arabia contributing a pledge of $300 million to work with non-OPEC countries in industrial countries toward...
I think the mic's not working. Can we get it on?
Am I okay?
Mic? Oh, there you go.
Yeah. To work toward CCUS in terms of defining projects, accelerating carbon capture, and so on. So that was a contribution initiated by OPEC Secretariat that was taken up by the OPEC countries. Now, it was supposed to be an international initiative with $1 billion being multiplying effect. It didn't work out exactly that way, but it did trigger activities within each countries, in particular, United Arab Emirates, Saudi Arabia. We have seen a lot being done. But the one thing that I would like to emphasize is still needed, and that is to invest more in basic and applied research in those countries. We still invest very little in research, whether it is on energy or whether it is on everything else. Most of our countries are still investing 0.2 to 0.5% of our GDP. We need to move up to 1% and 2%, and we need to put a lot of that into basic and applied innovation on how to make our assets, oil and gas. We're sitting on 50, 60% of the oil and gas assets in the world. We really have to take the leadership in making those oil and gas assets decarbonized, whether it is carbon capture, whether it is direct capture, whether it is hydrogen, converging it to hydrogen and capturing the CO2. So I think there is a lot for us to do. Some of the countries are beginning to do that, and some of their research centers, some need to do much more.
Looking from the Middle East, is there a country outside globally that you say is doing more on research? Is the model that you think the Middle East should follow?
Well, I think on research, I would say I will put Saudi Arabia on the forefront in terms of research, because many of their research centers, especially KAXT, King Abdulaziz City for Science and Technology, KAUST, they have taken up to do basic and applied research into how to decarbonize oil. I'm not going to go into the details there.
What about countries outside the Middle East that you think are doing good work that could be used as models?
Outside the oil-producing...
Outside the oil-producing world.
Well, before I go outside of the oil-producing countries, I want to sort of recognize what's being done here in the Emirates, because they've taken a leadership in carbon capture, and they have one of the largest projects and it's operating projects. So I think that's need to be done. Now, outside the OPEC countries, there's a lot of work being done in Japan, in Europe, and in the United States at the national laboratories, at the national universities. And I think most of the innovation I see coming out from countries that are taking the leadership: Japan, Korea, Australia, Germany, and the United States.
Wonderful. Mechthild, I wanted to ask you a question from your past life before we go to the IEA. You spent a lot of time at the EU, and most recently you were director for the Energy Directorate, which is looking at all of energy across the EU. You also had a position that looked at renewables, looked at research, looked at carbon capture. It's been said in the conference before that technology-neutral approach towards decarbonization is very important. What was your experience as in the EU, and where do you think were the hurdles in getting carbon capture and other oil and gas decarbonization techniques into the mainstream?
So thank you very much. Thank you also for inviting me here. I joined the IEA 3 months ago, so I understand your question is from my previous side, where I spent 10 years in the European Commission on energy and climate issues. So for Europe, they came out with a long-term strategy by 2050, carbon neutral, or climate neutral, as they call it. And we need indeed all kind of different technologies. In Europe, energy efficiency and renewables are very high on the agenda. They would like to push it. There are targets for 2030. We have 32% renewables and 32.5% energy efficiency. So we want in Europe to go that line. But it's also clear, which came out in that long-term strategy, with all that push for electrification, there are certain limits. And what we need to do is also, and I would see it personally in Europe as a small revival of CCUS or CCS, which hadn't been really taken off in Europe, and there might be 2 or 3 exemptions. First of all, I would start maybe with Norway, even though in the stricter sense it's not EU, it's Europe. They have done a lot on CCUS. They had done it in the past with the Sliper CCUS project in '96 already to capture CO2, and they had more recently started to work on CCUS with the energy-intensive industries, with Heidelberger Cement, to capture CCUS and store it on another place. So Norway is one of the good examples there. The second is UK. The UK has done a lot on CCS, and in my function as IEA, we have done a major CCUS summit in Edinburgh rather recently, in end of November, and it was really impressive how many high-level ministers, but also industry and the financial sector, which was probably new in that area, came to Edinburgh to discuss together with the Minister, Energy Minister Perry, the UK Energy Minister Claire Perry, and Fatih Birol, and many others about CCUS and the perspectives of CCUS. And a third example from Europe is the Netherlands, where the Port of Rotterdam, which is for the CO2 emissions, nearly 1/4 is coming from the Port of Rotterdam industrial business and production. So 20 to 25% of CO2 emissions of the whole Netherlands are coming from that area of Port of Rotterdam. And they have really, really stepped up all efforts to capture and store CO2 with the energy intensive, with the refinery. They got a consortium with industry there, and they hope to get it done and running by 2020. They got the money partly from the Dutch. The EU is also, they applied for funding from the EU for that, from the Connecting Europe facility. There are still a couple of things to be, but they're on a very good way that they have a clear and good project on CCUS in this Port of Rotterdam, combining the industry and the refineries and others in that area.
one big challenge for carbon capture, even though the technology has been around for 50 years, is that with the goal of decarbonization, it's still considered to be too expensive. So Norway's project that you mentioned is looking, Norway is a rich country, but it still is looking for funding from the EU. How is the EU or generally the finance world thinking to bridge that gap that needs to be made?
I think there are different ways. First of all, it depends on the carbon price. Secondly, if we have in Europe a project of funding which is connecting your facility, where we open it up also for CO2, and there are a couple of others in regional project or research project where you can get. But it's not only, at least in Europe for CCUS, it's not only the money you need, but it's also a public acceptance. And in the countries I mentioned, UK, Norway, and the Netherlands, they managed to get it. In the country I'm from originally, Germany, there's no way to get CCUS, at least at that stage, mainly for public acceptance reasons. And even in Poland, where there is a lot of coal, and in the past they have tried to combine, I mean, this has been developed further, but in the past, when you started coal and CCUS, like in Poland, in Betovice, where there is a huge coal power plant, it didn't really work. So I think we are now have stepped up. As I said, everyone I think who does long-term scenarios, be it the EU, be it companies, be it the IEA certainly, sees a clear need to go for CCUS and CCS. So I see a clear revival, including in Europe. But it's money question, it's carbon price, it's public acceptance, I think. But the appliances to go coal and gas, but also to industry, energy-intensive industry, and use the depleting oil and gas field to store it is something the Dutch, the UK, and the Norway, and much broader in global terms, are working on it.
I'm going to go ask Mr. Toyoda a question, but that's a signal to say, I am running out of questions here. You have to ask the next set of questions. Mr. Toyoda, Japan was brought up. Dr. Adnan brought up Japan, and Japan has had a strong stance on carbon capture. It is also an importer of natural gas, has been for decades, and will continue to do so. What is it that Japan is doing towards decarbonization of gas?
Well, thank you very much for our question, and it's a great pleasure to be here. Talking about Japan, when we try to address climate change,
You're Doria, right? Yes. Who's the person?
There are two or maybe three measures. One, introduction of renewable energy. Second, keep nuclear, hopefully keep it as it is. And thirdly, energy efficiency. But that is not sufficient to address climate change. And so we are trying to develop CCS technology, but unfortunately, there are not many sites to use this technology, even though we could succeed in developing CCS technology. So what we are trying to do is to decarbonize oil or gas or even coal outside Japan, and by using this CCS technology, we would convert those fossil fuel into hydrogen, and zero carbon hydrogen with CCS. Yes, there is another way to produce hydrogen from renewable energy through electrolysis, but for the moment it is very expensive. And so what we are trying to do is to develop CCS technology and using that technology outside Japan and try to decarbonize fossil fuel and produce hydrogen and import those zero carbon hydrogen. I think as we saw, even now, 80% of primary energy is fossil fuel. Somehow we have to convert that fossil fuel into zero carbon energy, and hydrogen could be one way to do that. And clearly, producing ammonia could be another, and producing zero carbon oil by using EOR technology with CO2. So there are various kinds of ways to decarbonize oil, but we are very much interested in producing zero-carbon hydrogen in Japan.
And Japan has led on hydrogen for quite some time now. You know, we can go out and buy a Toyota. I don't know if you can do it in UAE, but you can go out and buy a Toyota Mirai that runs on hydrogen fuel cells. But it hasn't taken off quite as much as electric cars have, for example. What do you think is stopping hydrogen from being used in transport, and especially if we go down the hydrogen route, the zero-carbon hydrogen?
Well, I think at this moment, probably it is not yet economically viable. Still, it is expensive. But by 2030, we think we could reduce the cost of producing zero-carbon hydrogen to the level comparable to gasoline first. And so it could be utilized for transportation first. And then, hopefully, in the middle of 2030, 2040, we would reduce the cost of zero-carbon hydrogen up to the level comparable to heavy oil. So it could be utilized for power generation as well. And hydrogen could be utilized as feedstock for chemical products. It could be utilized for heating. It could be utilized for chemical production. And so I think it could be very much interesting and useful zero-carbon energy.
I'm going to ask you to raise your hands for questions that you may have. And while you're doing that, I'm going to ask Jerome a follow-up question. A word that was used perhaps 3 times in the answer was unfortunately. And that's usually associated with carbon capture because it hasn't quite made the contribution that the technology is capable of making. The OGCI has, amongst its few decarbonization initiatives, a big push on carbon capture. What is it that's being done to accelerate it?
I think maybe first of all, we have a collective conviction as OGCI companies. The first one is that our traditional business models are about producing, transforming, distributing oil and gas products. And this is the horizontal part. And we need to add a vertical one, which is about making sure our customers, whether they are countries, cities, industries, or individuals, consume a better, cleaner, cheaper, more reliable energy. Which means that first, we need to look at energy efficiency. That's the beginning of the journey, the energy efficiency of our customers. Then we need to provide them a cleaner and cleaner energy, and hence the work, all the work we do on gas, and as well the work we do on efficiency of transportation for oil. Hence, we need to think about the fact that we are in a circular economy world. And therefore, we need to think about circular carbon, which I believe is the proper word for CCUS. Because in our chain, we have a waste, and that waste is CO2. So we need to see how we can use that waste, and if not, how we can capture it and store it, either industrially or through natural-based solution. So through OGCI, we have created a very strong CCUS workstream. And first of all, we do invest together in CCUS technologies through our CI investment arm. As you know, we have created a $1 billion fund together to invest in technologies that would help us to kickstart the industry and to make sure that it is actually one of the key industries of the future. And we are dedicating a significant part of that pot either to kickstart through commercial CCUS projects, such as one in the UK right now, or to support startups in order to help them to bring down the cost, the integrated cost of the CCUS chain from around $200 per ton to around $50 per ton, as we have heard from our Net Power friend earlier. So that we will do, we are doing this, and in parallel, we are working together and with governments in order to launch initiatives that would help the CCUS industry to really start. Because if we want to be at sync with a 2°C scenario, we need to be able to store and capture several gigatons of CO2 per year by 2030, 2040. So we don't need 1 or 2 projects. We need 20, 30, 40, 50 projects by that time. So we need to kickstart this project and launch them. This is what we are trying to do together.
And there are questions in the audience, but I'm going to ask a quick follow-up question on the point you've made. One of the companies that the OGCI is invested in, and you've invested in at Saudi Aramco, is Akatis Power. Could you tell the audience what that does? I feel like having startups that come up with new models and new technologies to cut emissions, as we heard from NetPower, is a great way of pushing innovation in this space.
Yeah, so as I think Jerome mentioned, efficiency is a great area and a quick way of reducing emissions overall. And the advantage of emissions, of efficiency, is that we have an installed base. 99.9% of all transport is driven by combustion engines. And if you just improve the efficiency there a few percentage points, it's tremendous impact. Whereas if you compare that to alternative sources, you're talking about a long-term impact. So we are working hard on basically improving the efficiency of the internal combustion engine. Today, light-duty vehicles are roughly in the 30% efficient range, mainly because they're using gasoline spark ignition. If we just go to compression ignition, we can boost that up by another 50%. So you can reduce emissions from the light-duty vehicle sector by 50% just by moving to another combustion mode. And that's what we're doing with Akatis Power. Akatis Power is an exciting startup which is doing opposed piston engines, 2-stroke opposed piston engines. It's an old technology, but it was difficult to engineer. And Akatis was able to apply modern technologies to engineer this and make it work. So we were very supportive, and we've done joint projects with them. We actually installed it in a Ford F-150. The Ford F-150 represents the class of vehicle, represents about half of energy fuel consumption in the light-duty market in the US. So if you can impact the light-duty trucks, you can tremendously impact the emissions of the light-duty vehicle sector in North America. So it's one of the areas we've collaborated on, really demonstrating this in an actual truck, driving the truck. And we're going to be showing that again in the next year's auto show. The idea is to get the automakers who are very interested in these new internal combustion engines to be able to really see the full life cycle advantage of improving the combustion. So as I said before, we're looking both at the fuel, which is things like the life cycle, full life cycle emissions of the fuel production, as well as how the fuel can enable efficiency in an engine. So we're looking at how to make gasoline, for example, run in a compression ignition engine. That means you can take a gasoline and do it at compression ignition efficiencies that's up to 50% efficient from 30%. So we're really talking about having real impact. If you take that 99% of the vehicles of the world or the transport systems of the world and improve them by 50%, that's impact in a short time. The challenge we face with other sources is that we tend to look at just the, for example, the tailpipe emissions. And we forget that those, even though we may eliminate those tailpipe emissions, those emissions are coming out somewhere in a primary energy source. And we don't really look at that. We just think, okay, we've solved the problem. No, we haven't solved the problem. We just moved the problem. The question is, how do you look at the full life cycle? It's very, very critical. In simple things, economically, can be done quickly. So I just give an example. When I'm in China, I say, look, if China wanted to lower their transport emissions by 10% immediately, just buy Saudi oil. You will reduce your full life cycle emissions in your transport sector by 10% because we're 10% less than the world average. I mentioned that 60 kilograms per barrel for the world average, 27 kilograms for Saudi oil. So there are simple things we can do. Prioritization, incentivization of best practices in the existing energy system. That's the kind of thing that can move quickly to reduce emissions. That's just one thing. But other things are carbon capture utilization. I have to respond to the point about the cost of carbon capture utilization. The cost is not the problem. Today, it is feasible. Technically, it's not a challenge, of course. We've proven that in many, many pilot projects. The cost is all relative. It's how much we're willing to pay. So, in fact, if we're willing to put the price on carbon-free electrons from willing to do it from a carbon capture utilization project with produces energy or hydrogen, then you will pay. It's actually cheap. You can produce electrons today, as we saw from net power, as cheap or cheaper than alternatives. So we're saying there is a place for hydrocarbons in the energy sector with carbon capture utilization for a long time to come. And that's one of the areas where I think cost is not really the problem. It's more about market and how do we get policymakers to make technology agnostic decisions, full life cycle decisions, policies that don't care about what the source of the energy is, but rather about the final emissions targets.
I'm going to take questions from the audience here. We've got microphones. There's Carlos on the left-hand side and Doria on the right-hand side. You can just flag yourself to them. I'm going to take the first question from the gentleman here. Introduce yourself and ask a question that's short. So, and if you can address somebody on the panel, that would be perfect.
This is Ashutosh from Mubadala Investment Company. This is a question for Mr. Ahmad. So you spoke about China and you spoke about how they can reduce the carbon emissions. And since we have been talking about greenhouse gas, China is going very aggressive on transformation or transition to electric vehicles.
Yes.
And not only cars, they're going into buses and trucks. So Shenzhen, for example, there are no internal combustion engine buses or taxis at the moment. Everything is replaced by electric vehicles. And China controls more than 50% of the electric vehicles supply chain, commodity supply chain. How do you see that? I mean, do you think, and the policy says that by 2025, they will be replacing 25% of their transportation with electric vehicles. How do you see that, that rapid transition?
Yeah, so I think if anyone can do it, it's China. China has proven with renewable energy that they can bring the cost down of solar energy tremendously. Today, it's cheaper than fossil fuels for the power of, for the production of electricity. And we have a lot of gratitude to China for the investment that they come. Not too much technology, by the way, mostly investment in production and scaling of production, which allowed the reduction. So I believe China can bring battery costs, for example, lithium-ion battery costs, to be competitive with light-duty vehicles, perhaps in the mid-2020s. We think if they continue scaling up production, that probably in the mid-2020s, they will be competitive with a certain sector of the light-duty vehicle sector. Of course, the challenge is that is a limited sector. We really are talking about energy density here. And there are two differences between China in the last 20 years and China in the next 20 years. I think in the last 20 years, we're talking about a China which was rapidly industrializing and willing to invest tremendous sums by provincial governments and the main government in technologies to achieve leadership in many technologies, such as solar energy. They have put those policies in place, we believe, number one, for industrial leadership. Number two, for local pollution reasons. They do really need to reduce combustion emission particulates and such in the local areas. Three, I think oil independence and the energy independence is one of the things that China, of course, looks at, as many countries do. And finally, climate. I think climate is a byproduct. It really isn't. CO2 is not the driving force for those policies. In my view, going forward the next 20 years, I think it's going to be a little challenging to maintain the kind of, let's say, investments that are needed if consumers do not choose so this is a difficult, I think it's a gamble on their part because they are basically asking the automakers to subsidize the electric vehicles by raising the prices of their combustion vehicles over the next 10 years. So it's an internal subsidies the automakers are being asked to make. We'll see if that really works. I think it's going to be a challenge. I do think if anybody can make it work, it'll be China. But assuming it does, that's 50% of, let's say 25% by 2025, 50% by 2030 of China's vehicles sold. You're talking about a stock of vehicles, the problem is. And so even with those very ambitious and very aggressive targets, we're still talking a few 100 million cars in 2030 timeframe, 2040 timeframe. Now remember, the world has added another 2 billion people. The world's energy demand has gone up by basically doubled by 2040, 2050 in that time range. So even if we bring in electric vehicles very aggressively, as China will be doing, we're still talking, with all the best projections, 85% of vehicles running on oil, basically, or oil-based products, internal combustion engines. So we have to meet that energy demand because it is the bulk of the demand. It's not, especially going into Southeast Asia, India, and the growth that we're expecting. We're still going to have a rising demand for oil, and that's why internal combustion engine efficiency is so essential. We have to continue investing. One of the challenges we face today, and I talk to automakers all the time, is that from the top, they are getting the message that there's no future for internal combustion engines, and therefore they have to stop doing research. And this is a big problem because we're throwing away an opportunity of 85% of the world's emissions in transport not being reduced by 2050 because we choose to go only the alternatives. No, we have to do all of the above. We have to advance alternatives, but we have to continue working on the bulk of the fleet. So I really think there are policymakers are moving a little bit in that direction, and we're seeing it in other places. We're seeing in California, we're seeing in Canada some good policies that are looking at full life cycle and not too much of this technology mandating. It's more about emissions targets and how do you get there, and we don't really care which technology you use to get there.
We have a question on the left-hand side.
Nasser Al-Tibi from Al Arabiya. Mr. Khowaiter, buy Saudi oil would make a great new marketing slogan for Aramco. A question to the panel. CCS proponents say clean energy isn't going to happen fast enough. But what if renewable energy uptake really picks up fast? Could this idle CCS investments today? How much of a risk is this? Thank you.
Jerome, maybe you could take that.
I mean, you know, even in the most aggressive sustainable development or 2°C scenario you can see, you still need CCUS in the magnitude of several billion tons of CO2 being stored per year in 2040, 2050. So even in these scenarios, the most aggressive one where renewable is increasing at an incredible rhythm, you need, by that time, a CCUS industry that is almost as large as the oil and gas industry today. So we cannot bet on the fact that something will be invented that will, I would say, prevent it to come here or will make sure it is not needed. We need to do our utmost to get that industry ready. And we believe that as an oil and gas industry, we are geared to work on it. Because at the end of the day, a CCUS industry is about the same as an oil and gas producing industry. You just do the reverse of what we are doing today. So these are the same competencies, the same engineers, the same technologies. Hence the fact that it is our responsibility from all points of view, including business responsibility, to work hard on it and make sure it is there to answer the challenge and to help us to come to a net zero carbon industry and world by the second term or the second part of the 21st century.
And I suppose a nuance to that question is that if there is any replacement of money being happening, if you've got renewable investment and you've got carbon capture investment, if some money is being taken away, so to speak, from the carbon capture side, are there regulations that need to be put in place that allow for government money to be used across all sorts of technologies? Maybe you can speak to that a little bit, Mektab.
I first wanted also to reply to that question. I mean, in our World Energy Outlook, and you have the new policy scenario where there is still a lot of oil and gas. But if you have our sustainable development scenario, which include climate change, air pollution, energy access, and so on, and there is an increase of 230% of renewables and a lot of energy efficiency, we even have an electrify scenario where we push it all to the top, you still have nearly half, 45% of oil and gas in our energy demand. So what to do in order to get CO2 reduction? So one clear way is CCUS, even though for the time being it's quite minor. It needs to increase, like hydrogen and other ways of decarbonization. We need to decarbonize, that's the topic of this, oil and gas because it stays with us. So whatever means there are, and CCS is one of the prominent one, we need to push that technology like others in the future. And I wanted also to react maybe to one other on the oil demand and the transport sector. It's clear today 90% of oil is in the transport sector. Transport is 90% oil. There will be a change towards 2040 where there's a lot of electrification in transport, certainly in the US and and Europe. But if you then look where the oil demand comes from, and we did a report on that, it's the petrochemicals. 50–60% of the growth in oil demand will not be from transport, but it will be from the chemical and petrochemical sector. And we will still use, we have everywhere plastic and all forms of chemicals and petrochemicals we use in our daily lives. So there will be a shift from oil use in transport and oil use in petrochemicals, at least in US and Europe, quite significantly.
And it's starting to happen already. I think the most recent figure that Mr. Khowaiter gave to me was global oil demand, about 57% is for transport, so it's already starting to reduce. Yeah. You have something to add, Mr. Toyoda?
Well, one thing which I wanted to add is that the energy mix could be different among countries. For instance, renewable energy, solar PV, here in this region, perhaps capacity factor could be 30% to 40%. But in Japan, the maximum capacity factor for solar PV could be 12%, 40%. So it's almost half. And when you talk about Asian countries, yes, China, they have a lot of land, and so they could have a lot of space for solar PV and even for wind power. But in Japan, it's a mountainous country. We don't have much space for wind power either. And so I think when we think about the energy mix, all energy cannot be perfect. All energy can be applied to all countries. And so I think we are trying to, as Japan, we are trying to renewable energy as a major energy, but there will be a limit. And nuclear, from the standpoint of safety, there might be a limit. And so we need something zero carbon, which could be decarbonized oil.
Yeah, and Dr. Eldin?
Well, I want to address the question about the investment. Let's just put it in perspective. I believe the numbers for CCS total investment so far has been around 14–15 billion or something of that sort. I think investments in renewable just in the last average, in the last couple of years, it's been approaching 1 trillion. So I don't think the question is taking investment from CCS to renewable will make any difference. On the contrary, I think what's needed is that to make sure that we invest enough in each and every one of those options. Let me remind ourselves that in the 70s, any investment in renewable was dismissed as being too premature, too costly. I remember in Kuwait and Saudi Arabia, we were engaged in solar research, and our institutes were ridiculed for having entered into this thing. So I don't think we need to make that mistake. Let me just take this opportunity and say what is needed is not only to push ahead to accelerate CCSU for the reasons that have been mentioned. According to the IPCC recent report in November this year, prior to the Scotland meeting organized by the IEA about CCUS, it was mentioned that if we were to avoid 1.5 degree, rising above 1.5 degree for the catastrophic reasons, we need to fulfill all of the CCUS promise, and that's not sufficient. So we need to go into other ways of the removal of CO2 from the atmosphere. And I said in my opening remarks, that is something that our countries here in this part of the world has also to begin to explore, how to take CO2 from the atmosphere in order for us to be able to export oil and gas. That means we will not just compensate or reduce the CO2 in the production, but we will anticipate the emission of CO2 in the use of the oil, and we can export CO2-free barrels of oil because we have offset them. Of course, the cost right now is very high, somewhere between $300, $600 per ton. But with innovation, we know just using the renewable, 40 years ago, it was dismissed, and today it is fine. The final point about renewable is that we are not factoring in all of the cost of renewable. Integration, I'm not going to dwell on it. Integration is a very important part of the cost that currently it's being dismissed. It's not factored in. Another final point about renewable, imagine today we have 500,000 turbines, wind turbines. And just assume they stay like this, we will have to start replacing some of them. Some of them are only good for 10 years, some of them are good for 25 years, depending whether they are offshore, onshore, all technology, new technology. What are you going to do with all of these wind turbines? Good question.
We have a question that side.
Thank you to the distinguished panel. I guess the question's mainly for Mr. Khowaiter, but could be for the entire panel. We're in the middle of the Industrial Revolution 4.0. We know the industry was a pioneer in terms of using sensors back in the day, but there's a sense that more could be done to use artificial intelligence, machine learning, this huge amount of data that comes in, especially in the upstream, to increase efficiency in output, reduce imbalances between supply and demand, so on and so forth. Any specific examples from your work that you're doing right now to take advantage of these new technologies?
Sure.
Thank you.
So as an oil industry, as you know, we're big users of data. We have been, after the aerospace industry, probably the most aggressive in the adoption of computation to our industry. And so one example of that has been Aramco's long-standing leadership in reservoir simulation. So our TerraPowers, which is the latest iteration, trillion cell simulator, basically allows us to simulate our reservoirs, the largest reservoirs in the world, to a resolution of 1 trillion cells. And that allows, tremendous advantage in terms of efficient and maximum recovery of our oil. So we've been doing this. Of course, that's more of what you might call the rigorous modeling approach. We've moved into cognitive approaches, artificial intelligence approaches, not to the simulation of the reservoirs, which are pretty well understood, but rather in toward the discovery side. So on the seismic, for example, in the seismic processing and the identification, for example, of traps and such, the human interpretation part is ripe for automation and fourth industrial revolution technologies. And there's a lot of that in the oil industry. There's a lot of cognitive knowledge that makes the difference between basically a good producing well and a lousy well. And that cognitive knowledge, if you put it all together, is a perfect solution, is a perfect application for artificial intelligence. We have a lot of research projects in that area in our Upstream Research Center, XPEC, where we're looking at how to apply these new tools. And we're collaborating with a number of partners around the world. We have centers across the world. We have our center in Houston, which is our biggest out of the kingdom. We have a center in KAUST, King Abdullah University of Science and Technology, working with the cutting edge scientists in the universities on developing new algorithms and new approaches. In terms of using AI on the surface, we are also very much leaders in that area. We have a lot of work in prediction of failure. So we have the world's largest data repository for process facility data. We get 3 billion data instances each day into this center where we process and identify failures. We try to predict failures for our refineries, our gas plants, our gas oil separation plants. It's one of the wonders of the oil world, in my view. It had allowed us, for example, a few years back to reduce our gas flaring. So now we're the world's best company in flaring, in reduction of flaring. We're down to 0.5% of our gas flared per barrel. So that makes us the world's best, we believe. The Kingdom just joined the Zero Routine Flaring World Bank organization, although we should have probably joined 40 years ago because we started this, we believe, but that's okay. And one of those technologies that we used was one of these fourth industrial revolution technologies, which is basically AI applied to prediction of flaring, to tell the operators to basically go out and find this problem and solve it, because it actually tells you that your plant is not behaving properly. So this is the kind of, I think, huge value. You save gas, you reduce your emissions, and it's AI-based.
We're coming to the close of the session and don't want you to stop you from having coffee. We'll have one question and one more question, so if there's somebody, you should raise your hands now.
Adnan Trainer here. Actually, thank you very much, and to all of our panel here. Without a doubt, all the great work that's going on, I think, in this region and in this arena is incredibly admirable, but I think the people missing this message are the general public. And I think this is perhaps a role, maybe Jerome, that is something that your organization needs to really take on board and to really push out there, because right now there's still a huge divide with us and them. And I think until we get the general public on board and until we can begin to hear from people outside this industry what a great job that the oil and gas industry is doing in terms of being part of the solution, then I think we're really missing sort of closing that circle here. What particularly can you do, since you are a CEO-driven organization? And indeed, I think everybody has a responsibility here. IEA, I mean, you all have to make sure that there's a stronger message going out there, because it's not happening.
I think you're right. I mean, we need to do better. We are 4 years old as a GCI, and every year we try to do better and better. And as you can hear from Ahmad, for instance, we truly have companies leading by example. Now we need to explain this. The oil and gas industry has to be part of the solutions and has the technological means, the understanding, the global footprint that would and should enable it to clearly bring the solutions. And as we have seen on climate change, there is no silver bullet. And therefore, we need to work on many different directions. And we cannot work individually. We need to work together. Because individually, we can only go somewhere. Together, we can be far better than the sum of the parts. And this is what we try to do as part of a GCI. We do represent, as I said at the beginning, 30% of the global oil and gas production, 20% of the global energy demand supply. So we can bring something. And our CEOs, the CEOs of the 13 oil and gas companies, are truly committed to contribute to bring solutions on climate change. So we will be more and more vocal, and we are working on that, engaging, targeting, investing together.
One last question here.
Thank you. Dan Dorner, Head of International Energy for the United Kingdom. Thank you to the panel. I just wanted to offer one comment and one question. So with regards to the CCUS International Summit that we were honoured to co-host as the UK with the International Energy Agency, something that struck us was just the level of commitment, in particular at the very highest levels from industry, including Aramco, many OGCI members, but also China Energy, lots of others as well. The level of commitment at the most senior levels of decision-making, the ones that really decide the direction of the companies, was there, and was very impressive to see. A commitment that we took from that was to demonstrate that we don't just want to show our commitment to CCUS at that one event on that one day. We're taking the messages from that, then took them on to COP. We then take them on to Davos. We're going to continue that messaging, which very much speaks to trying to generate the public acceptance point and to show that governments as well as companies are very committed to see CCUS taken forward. I suppose it also speaks to my question, which again I think came to a comment that Dr. Shihab-Eldin said, which is one of the things that we're observing across the oil and gas sector is just the real diversity of strategies of decarbonisation that seem to be there. Not just CCUS, but you see companies going in various biofuel technologies, Shell investing in a utility company, fast charging of electricity infrastructure. And I'm wondering, is this going to be the path that we continue to see? Is it going to be a diversity of corporate strategies, or will there be consolidation of approaches and strategies as we go forward? So I'm interested in your thoughts on that. Thank you.
At least I can tell you one thing, which is as part of OGCI, we try to share all these strategies and to extract the best of each of them and to pull them and to pull and push each other. And you cannot imagine how much each of the companies is pushing and pulling the others to go faster. And you gave very strong example of what Shell is doing, but what Saudi Aramco is doing as well as being inspiring other companies. And CNPC was telling us very recently that they would have done probably 20% of what they are doing now if they had not been working with the 12 other companies to basically be inspired by what they were trying to implement. So we are trying to act as a catalyst to basically take the best of what each of them is doing.
Dr. Adnan wanted to add.
Yeah, I think it's not clear what the answer will be. I think for the short term, you're going to see a diversity in the strategy for a good reason, because we don't know which one will actually have the most payoff. And even if we get to know that, I think it would be a mistake, because you should not be blinded by the short-term returns, because we are dealing with a 40 years to 100 years. And I think where the problem lies, or has been lying, is that investment by IOCs and NOCs in R&D and innovation has been very low for a good reason, because they were making money very easily. Because the rate of R&D investment relative to sales in the energy sector or in oil and gas sector has been less than 1%. In pharmaceutical, it's 10%. In INT and informatics, computer, it's 8%. And I think that's a mistake, because even IOCs kind of relinquished their leadership in R&D to the service companies, to Schlumberger and things like that. They were mostly looking at how to maximize the bottom line, which was very easy, get assets that are cheaper, and let the service companies worried about that. That's no longer the case. We have assets, especially in our part of the world. We really have to start investing in everything possible. And I think it's correct for example, national oil companies to look at a diverse strategy. For example, KPC in Kuwait just announced that they will be investing in 1 gigawatt solar project for their upstream operations. I think that's good, but that's not sufficient.
Maybe just to react on the two issues. On CCUS, we certainly heard it a lot more in COP than in previous COPs. I've been to many COPs, and this time it was triggered by the IPCC report on 1.5, but also, I think, on our follow-up of the conference and so on. So we will, as IEA, take that up also in the IEA ministerial in this year. So the issue will continue to be debated, and I agree fully that we need more public debate on these kind of issues to involve more stakeholders. Secondly, on the question of the strategy, I think there's probably not one strategy, and it depends very much on the region. Like Japan has other possibilities than maybe Europe, US, so we need to look at all technologies and all possibilities. We need to go for renewables and energy efficiency, but there are obviously limits in some areas of the world, and there are much more opportunities in others. China and India will be the main driver of the energy demand in the future, and they are doing a lot in all of our technologies. We only see maybe a difference when it comes to nuclear and coal. Nuclear and coal are going down in Europe and US in the energy demand growth, and they are taking up mainly in Asia in energy in China and India. So there are some regional differences, but overall, I think from a strategy point, we need to look at all and diversify, at least in the short and medium term.
Thank you. I'm sorry I've run out of time. It's great to have more questions. I hope you can follow up with the panel. If you take one thing away, it is that everybody needs to do more. Everybody in the audience, everybody on the panel, and I hope you can hold each other accountable to do more. Please thank our panelists.
Thank you. Very nice, very good discussion.
And now I'm going to hand over things to David Livingston, Deputy Director of Atlantic Council's Global Energy Center.
Thank you, Akshat. Great panel. Thank you very much again to our distinguished panel. Ladies and gentlemen, we heard something that continues on a theme which is run throughout this Global Energy Forum. which is that when it comes to the global energy transformation, it is not just about unlocking new energy resources and technologies, but it is truly also about going back into the incumbent energy resources of today and innovating in them so that they become more abundant, more cost competitive, and more carbon efficient as we enter the 21st century. Now, as we head to a break, a brief 15-minute break, please, as we try and catch up, I just want to remind everyone that we'll be following this up with a panel you've all been looking forward to on Belt and Road. So please take a brief 15-minute break, stretch your legs, and join us back in here for a terrific dynamic panel on Belt and Road just ahead. Thank you.